Alright, let's talk special right triangles. Hopefully you did this last year in geometry, but just in case you forgot, I'll pretend you haven't done it, and we'll see what we can do here. So my special right triangles, there are two. There are the 30, 60, 90, and there are the 45, 45, 90 triangles. So let's start with our 30, 60, 90. The black pencil. So I'm going to draw myself a 30, 60, 90 triangle. Ooh, that's really thick. Let's narrow that down. So on this triangle, I'm going to make this smaller angle 30 degrees. This is 60 degrees down here, and of course our right angle right here is our 90-degree angle. First thing you want to do is remember that the names of what we like to call these sides. So remember from triangles, the shortest side of a triangle is always across from the smallest angle. Since this triangle, this 30, 60, 90, has a small angle of 30 degrees, the side across from that is going to be our shortest side in the triangle. So we're going to call that our short side. From the right angle, we know that across from a right angle, we always have the hypotenuse. So it's still going to be called the hypotenuse. And then that makes this side across from the 60 our long leg, our long side. So if I tell you the short side of a 30, 60, 90 triangle is, we'll do it with variables first and then we'll switch over to numbers. I'll tell you the short side is x, some number that we know. To get the hypotenuse, now here's how you're going to remember this. You don't have to just memorize. If I draw this triangle, and I say all three sides are the same, and then I draw in an altitude right here, that means that these angles are 60. This one up here at the top of the triangle was 60, but now I've cut it in half with my altitude. So now I have two 30, 60, 90 triangles. Well, when I started, if all my sides were the same, they were all x. But as soon as I drew this altitude, we cut this base side in half. So this is 1/2 of x, or another way to write it is going to be x over 2. So my short side is half of my hypotenuse, but if I go the other way, to go from half of the hypotenuse to the hypotenuse, I'm just going to multiply by 2. So if my short side is x, I'm going to call the hypotenuse 2 times x. The long side, do this one in blue maybe. The long side of our 30, 60, 90 triangle is going to come from the Pythagorean theorem. Yay, Pythagoras. So here's our 30, 60, 90 triangle. 30, 60, 90. We want the long side. We know the short side is x. We know the hypotenuse is 2x. I want to find the long side. So because this is a right triangle, we get to use Pythagorean theorem. Remember, the hypotenuse goes in for the long, or for c, so I'm going to go 2x. Remember, that needs to be in parentheses because we have to square the whole 2x, not just the x. I'm going to put the x in for the a, so I'm going to have an x squared plus the long side. Let's just call it, I don't know, let's just leave it as a b for right now. So I got a b squared. I want to solve for b. So I'm going to start by squaring my 2x squared. So I'm going to have an x squared plus b squared equals 2 times 2 is 4x squared. Now if I subtract an x squared from both sides so that I get the b squared by itself, that's going to leave me with a b squared is equal to a 3x squared. But I don't want 3x squared, or b squared, I want b. So I'm going to square root. Whatever I do to one side, same thing happens on the other side. I'm not going to write plus or minus because these are sides of a triangle, so they're all going to be positive. So I get b is equal to the square root of 3x squared. Well, if we talk simple radical form, then we can go back to the pencil. We can go b is equal to, I'm just going to show extra steps. You won't have to do all these steps every time. 3 times x times x. If I jailbreak this, this x is going to come out in front. So b is x, which was our short side, times the square root of 3. So we just proved, and now you can go back and recalculate if you need to know how to find the long side. So let me go back up. So now I know that this long side is the square root of 3 times whatever my short side is. So to go from the short side to the long side, we're going to multiply by 3, not 3, by the square root of 3. And to go from the short side to the hypotenuse, we're going to multiply by 2. That's kind of sloppy. By 2. So the secret, I think the secret to these is find the short side as fast as you can. As soon as you get the short side, let's get some color here. As soon as you get the short side, come on. Is that showing up? Let's go bigger. As soon as you get the short side, then you can go from the short side to the long side and the hypotenuse. Let's go on to our other special right triangle, our 45, 45, 90. Let's go with a new color here. Just because I can, why not, right? How about, I'll try purple. All right, so here is my 45, 45, 90 triangle. Now if those two sides are 45, and I have a 90-degree angle, since these two angles are the same, we also know that the two sides are the same length. So you want to watch for that, because sometimes you can use the two sides the same length and the right angle to know that you have a 45, 45, 90. So let's say I know the side. Now on these two sides, we just marked with the double tick marks, they're the same length. So whatever they are, they're x. And the word we use to talk about these is the leg. These are going to be the leg of our 45, 45, 90 triangle. And across from the 90 is always our hypotenuse. So let's say I know the two legs and they're the same, and I want to know the hypotenuse. So Pythagorean theorem again. Hypotenuse is always c. Don't know the hypotenuse, so I'm just going to leave the c there this time. The two legs I've labeled as x's, so I'm going to put my x's in for my a and my b. I have x's, two x's squared being added together. When I'm adding things with the same variable with the same exponent, I just add them up. I'm going to have a 2x squared is equal to the hypotenuse squared. Now I'm trying to solve for the hypotenuse, so I don't want c squared, so let's square root both sides of that. I'm going to have the square root of 2 times x. This is looking familiar, right? Is equal to c. But I can jailbreak, that's our word for it. We're going to break those x's out. There's two of the same number, and they're going to be positive because they're sides of a triangle. So we're going to have x times the square root of 2 is equals to c, which we called our hypotenuse. So to get the hypotenuse, we're going to take the leg that we know, which we called x in our diagram here, and we're going to multiply it by the square root of 2. Now, this is my silly way of remembering that the square root of 2 goes with the 45, 45, 90. It's just silly, but see how you have two angles that are the same, two sides that are the same, and that's when the square root of 2 comes in. So that's how I remember that square root of 2 is part of that problem. Okay, so now let's work with some examples. Where'd my picture go? Here I have that's interesting. I have a 30, 60, 90 triangle. Oops, let's go back to the pencil. Let's make it black. I have a 30, 60, 90 triangle. I'm going to say that this side across from the 30 is 3. And I want to find x and y. So I know this is a 30, 60, 90. I'm going to put the names of the sides on here. So this side across from the 30 is my short side. I have my hypotenuse across from my 90, and then this side across from the 60 is going to be what we're going to call the long side. So x is the long side, is going to be the short side, which is 3 times the square root of 3. Y, which is our hypotenuse over here, we're going to take the short side, which is 3, and we're going to multiply by 2, and we're going to get 6. So then what if we have, another way you're going to see the 30, 60, 90 is you're going to have 30, 60, 90. Now, this is not drawn to scale. So I want you to use your head and think about, if this is a 60 and I tell you this angle is 90, then you know your 30 is over here, and I would recommend writing it in there. Across from the 30 is my short side. Let's say this time I know the short side is, do I want to do it that way? I told you the short side last time, didn't I? This time I don't know the short side. I do know the hypotenuse, let's say. The hypotenuse is going to be 14. And I want to find, I'm going to call the short side x and the other side, which we know is now the long side, y. So if I'm going to find x and y, x is the short side. If I know the hypotenuse and I want to get to the short side, I know that 2 times the short side gives me the hypotenuse. So if I go backwards from the hypotenuse, I'm going to divide by 2. So I'm going to take my 14, I'm going to divide it by 2, we're going to get 7 for our short side. Our long side, which is the y, is going to be the short side, which we now know is 7. Notice I'm putting that 7 on my diagram so I can use it. I'm going to take my 7 and I'm going to multiply the short side that I know is 7 by the square root of 3. And that's a simplified answer. Let's do some 45, 45, 90s. So let's say we have this triangle right here. I tell you this is 45, I tell you this is 45. Which means if all the angles of a triangle add up to 180, that other angle has to be 90. I also know that those 2 sides are going to be the same. If I tell you, now remember we're calling these on a 45, 45, 90, we're going to call these 2 sides legs. If I tell you one of these sides is 7, then we know the other one's the same, so I have to put a 7 there. And to go from the leg to the hypotenuse, you just got to remember our special number on here. 2 angles the same, 2 sides the same. So on this one we're going to use our magic number as the square root of 2. We're trying to get to a bigger side, so we're going to take the leg that we know and we're going to multiply it by the square root of 2. And one other way we can see this. What if I give you another 45, 45, 90? Again, because these 2 sides are the same. Because it's a 45, 45, 90, we know the 2 sides are the same. This time, let's say that we know the hypotenuse. I'm going to tell you the hypotenuse is 100. And these 2 sides we're calling legs. So all we have to do is find the legs. Well, up above, when we knew the leg and we wanted to go to the hypotenuse, you know the hypotenuse is always the longest side. So we multiplied by the square root of 2 to make it a bigger number. Well, now I want to go from the hypotenuse back to the leg, which is going to be a smaller number. We know our magic number on these triangles is the square root of 2. So I'm going to come down here and get my leg. I guess I could have called it x or something, huh? And I'm going to take the hypotenuse. I'm going to divide it by our magic number, the square root of 2. So my leg, if I call it x, is going to be the 100 in the hypotenuse that I know, divided by our magic number, square root of 2. But we never, ever, ever, ever leave our answers with radicals in the denominators. Actually, sometimes we can, but in big ideas, those answers won't get marked as correct if you do. So I'm going to rationalize the denominator using our multiply by 1. That's going to give me 100 times the square root of 2 on the top over square root of 2 times the square root of 2 is 2 on the bottom. Now one more step. 100 on the top, 2 on the bottom. Those are both even, so I'm going to divide. The 100's going to, no, the 2's going to turn into a 1. The 100's going to divide by 2 and turn it into 50. So our final answer here for our leg is 50 times the square root of 2. That's it for this one. Bye.